In this series of videos, we're going to be learning about logarithmic functions. A logarithmic function is the inverse of an exponential function. A logarithmic function is the inverse of an exponential function. And the exponential function that we just got done learning about was y equals 2 to the x. That's an exponential function. And that's what I've written right here. So this right here is an exponential function. I'm going to write that. That's an exponential function. And this right here is exponential form. So there's a difference between exponential function and exponential form. Now, a log function is the inverse, and we know that with the inverses, we switch the x's and y's, and when we do that, we get x equals 2 to the y. So what I'm doing is I'm looking right here. I switched the x's and the y's, and I got x equals 2 to the y power. That is a logarithmic function, but we write logarithmic functions in terms of y equals. So this is how you would write that. Y equals log base 2 of x. That is a logarithmic function. A logarithmic function. This right here is log form. I'm going to shortcut and say log form. And this one right here is exponential form. But both of them are logarithmic functions. Both are logarithmic functions. So when x is in the exponent, it's an exponential function, and when y is in the exponent, it's a logarithmic function. We typically write exponential functions in exponential form, and we write log functions in log form. And that's what we have right here. A very general form would be y equals, and how we read this is log base b of x. So I'm going to write that down. Y equals log base b of x. That's how we would say that. Okay, so let's look at some common logarithms on your calculator. You've got a log button and you've got an ln button. The log button is a log base 10, and the ln button is a log base e, And we discussed that e was approximately 2.718. So I'm going to write that on the left-hand side. I'm going to write this is a base 10. So the log button on your calculator is a base 10, and the ln button is a base e. So base 10 would look something like this, log base 10. But because it's so common, this is literally the common log. Because the log base 10 is so common, they don't put the 10. And because e is a second favorite, they call that the natural log. And it is log base e. So this right here is the shortcut, or you can call it an abbreviation. And this one right here, instead of writing log base e, it means the same thing. We just put ln. And then of course you could put any base that we want. Bases are going to be values that are positive, non-positive numbers that are not a 1. And we'll get a little bit more into that as we get more familiar with logarithms. So let's just go back and forth between exponential form and log form, and I think that you're going to get the hang of it. So we want to rewrite 2 to the 5th equals 32 in logarithmic form. So we need to know what we have here to begin with. We have a base of 2, so the base is 2. We have 5, which is the exponent. 5 is the exponent. And then we have 32, which we're going to call the argument. That's the argument. You might even see some people call it the answer, the argument. It means the same thing. I'm going to use argument because I do use that language, that terminology later on, and I don't want you to get confused by that. So I am going to call it the argument. Now, we've got a log base, and that base has to be greater than 0, but not equal to 1. But not equal to 1. So we've got log base, and that base is a subscript, and then we've got the argument, and the argument is no longer a subscript. It's going to be on the same line or that same level as log for log, and then that equals the exponent. Now, when students are learning to do this for the first time, they're not quite sure how to write these. So I break out the lined paper that we learned to write a long time ago with. And we're going to rewrite this 2 to the 5th power equals 32 in log form. So I'm going to draw a little arrow, and I'm going to show you what that's going to look like. We've got log, and then base 2. So base 2 of 32 is equal to the exponent of 5. And then I check to make sure 2 to the 5th power equals 32. Correct. 2 to the 5th power equals 32. So now I'm going to write it without the lined paper. And it's log base 2 of 32. I usually put the argument in parentheses, equals, and then 5 is going to be the same size as that 32. And that is how you rewrite an exponential form into log form. So the key word here is form. We're just writing this in log form. And that's our answer. Let's try another one. We've got e to the 1st power equals e, and we want to rewrite this in log form. So I've got my base of e, my exponent of 1, and my argument of e. So I'm going to start with log base e of e equals the exponent of 1. I'm going to check e to the 1st power equals e. E to the 1st power equals e. That is correct. Now, there's something special here, though, about this log base e. And log base e is one of those common logarithms. It's called the natural log. So we're going to replace that with ln. So I'll have ln e equals 1. So when I have log base 10 or log base e, I'm going to Okay, let's try another one. we've got 3 to the negative 2 power equals 1/9. We've got our base of 3, our exponent of negative 2, and then our argument of 1/9. So we have log base 3 of 1/9 is equal to negative 2. I'm going to check to make sure I wrote that right. 3 to the negative 2 power equals 1/9. So I just kind of make this little loop, and I'm going to show you this little loop in purple. 3 to the negative 2 power equals 1/9, and that is true. So our answer is as boxed. That's rewriting our exponential form in logarithmic form. Now, I believe that we have another example, and then we have a couple of tries. And the reason the next one is an example is because of that base 10. So kind of be thinking a little bit forward. Because we have this base 10, how might our final answer look? We've got log base 10 of 1,000 is equal to 3. Now, log base 10, there are 2 logarithms that we need to be very aware of. The log with a base 10 and the log with a base e. Log base 10, we're going to rewrite that as just a logarithm with log. Log of 1,000 is equal to 3. Now, when you see a log that doesn't have a base, a subscript, and it's log, you know that that subscript would have been 10. It's a common logarithm. So you would say 10 to the 3rd power equals 1,000. Okay, here's 2 for you to try. So go ahead and give those a try and press pause. And when you are ready to come back and check your answers, you can come back, and then we're going to discuss one little thing at the end, and then we'll be ready to move on. Okay, if you didn't press pause, please press pause. Make sure you're giving this a try for yourself, otherwise you won't know whether or not you've got it. The answer here is log base 15 of 225 is equal to 2. And the next one is log base 11 of 1 over 121 is equal to negative 2. Now, I want to talk just quickly about the positions. We've got our base, and I can write it anywhere. We've got our base, so the base. Now, there's restrictions for the base. Has to be greater than 0, but not equal to 1. And then we've got restrictions on the argument. The argument has to be greater than 0, must be greater than 0. It can equal 1, but it cannot equal 0, and it cannot be negative. And then our exponent is in this position right over here, right here. That's our position of our exponent. Our exponent can be any real number. Any real number. So if you have a negative number in the base, it is an undefined value. If you have a negative in the argument, again, you have an undefined value. If you have a negative in the exponent, that is completely allowed. If you have a 0 in the base, a 0 in the argument, undefined. But if you have a 0 in the exponent, it can be any real number, so 0 would be allowed. Okay, in the next video, we're going to go back and we're going to write in exponential form. So you can see that we've got a few examples here. We'll be writing those in exponential form. and then we will be evaluating. So we'll see you in the next video.